is introduced. In the system having to calculate zeta overshoot decay ratio frequency natural frequency y max and y infinite. You solved yesterday one problem. This is a repeat of the yesterday's problem. First thing is translate this into a standard second order system. So what is the standard second order system? Y by x equal to 10 by 4 divided by month. So what is tau square is 1 by 4. Tau. What is tau is 1 by 2. So zeta is equal to 0.4. Now calculate all the values. Overshoot is a formula, decay ratio. What is overshoot? Exponential of minus pi zeta by top 1 minus zeta square. So what is the answer that you are getting? Zeta is 0.2. Yeah. Overshoot to how much you are getting? 0.253. Decay ratio, which is 0.253 whole square. Frequency. One by tau, which is 2. How do you calculate Y max? Y max is nothing but A plus B. What is B is nothing but Y infinity. How do you calculate Y infinity? Limit S tends to 0, S into Y of S. Limit S tends to 0, S into 3 of S into 10 by 4. S and S will cancel. S if you put 0, then what do you get? 30 by 4, which is X is 4 by S. 40 by 4, which is 10. Now what is A? A is 10 into 0.253 because 0.253 is A by B now. So what is A is 2.5. What is Y max is 2.5 plus 10, which is 12.5. So sometimes this gate questions can be what is the fractional overshoot, what is the percentage overshoot. This you can write it as 25.3%. Depends on the question. In the question, if he asks, let's say, fractional overshoot, then 0.253 is the answer. If he asks, let's say, percentage overshoot, then 0.253, 25.3 is the answer. The next one is tanks in series. So now we know the transfer function of a liquid level tank. Let's say this is a liquid level tank. Let's say Q naught with the level outlet. This is let's say H1, area is A1. What is this function is H1 by let's say R1. So this is Q1. Now this Q1 is going to another tank placed like this. Clear? So this is Q2. Now H2. This is let's say H2 by R2. So this is two tanks connected like this is called as non-interacting systems. Non-interacting systems. They are not interacting. So here what I am interested is, suppose here this is like this. This is one system with the input X connected to second system with the Z. So X is the input to the first system, then Y is the output of the first system, which is an input to the second system. So then Z is output. So here, what is the transfer function Z by X? So we are interested. So here, what is my question is, suppose if you change this Q naught, how the dynamics of H2 will change. So basically, we want to derive the transfer function H2 of S by Q naught of S. H2 of S by Q naught of S. Can you try to derive this transfer function? So how do you derive this transfer function? Basically, the result is what we know, which is product of individual transfers. So Q naught minus Q1 is equal to A1 into dH1 by dt. Q naught minus H1 by R1 equal to A1 into dH1 by dt. Clear? So from this one, what is the transfer function Q H1 of S by Q naught of S equal to R1 by A1 R1 S plus 1. What is for the second one? Q1 by Q2 equal to A2 into dH2 by dt. So what is Q1? H1 by R1, H2 by R2 is equal to A into dH2 by dt. So what is from here? If you write H1 2 of S by H1 of S, what do you get is R2 by R1 divided by A2 R2 S plus 1. Now what is H2 of S by Q naught of S? Is nothing but product of individual transformations. That is R2 by A1 R1 S plus 1 plus A2 R2 S plus 1. So basically it is product of two individual transformations. Now interacting systems. Interacting systems. Q1. Here it depends upon both levels because you have these experiments in your UG lab also. Q1, what is Q2 is H2 by R2. So this is what is interaction. Flow will be in the forward direction and backward direction also. Forward direction, H1 is greater than H2. Backward direction is it is greater than H1. So that is why this is called as interacting systems. Can you derive transfer function here? What is H2 of S by Q naught of S? Not important gate point of view, these things. వస్తుంది అన్నట్టు రాకపోతే I'm trying to derive this equation. So I written Q1, Q0 only. This is all known story. So nothing is, let's say, not important. That is, I'm not stressing more here. H2 of S by Q0 as what you will get is R2 by tau 1 tau 2 S square plus tau 1 plus tau 2 plus A1 R2 S plus 1. So this is the extra term, which is actually called as the interaction factor. What is difference between non-interaction? See, this is the extra term. What is tau 1, tau 2 is? Tau 1 is A1 R1, tau 2 is A2 R2. This is interaction factor, interacting and non-interacting systems. Let's see the entire interaction and non-interaction ones. Any questions you have? See, what is significant difference between interaction and non-interacting is, in non-interacting, the effects will be only in one direction. So that means first system will have affect the output, that will output will be second effect. If there is any changes in the, see, basically effects are going in the forward direction. There is no reverse direction of effects. Whereas if you take in the non-interacting, effects can go in the forward direction and reverse direction. So by default, the systems in all the chemical plants are non-interacting only. Even though you have recycle, but the effects will be going in the forward direction. Understood? Yeah, that's, I'm coming there. Now, responses. So if you see the responses, response. If you see the response of, let's say, interacting and non-interacting, let's say if you compare H2 with respect to time. So this is how non-interacting, this is how interacting. So interacting systems are slower. So interacting systems are slower. Interacting systems are slow. Because of the effects, because of the sluggishness in the system. Now, if you take, let's say, non-interacting, let's say if you take non-interacting is one directional, interacting is bidirectional, H2 and H2. So if we compare the responses here within non-interacting, then the effects of first system are faster, second system are slower, because second system will become a second order system. So this is H with respect to time. So because when I'm writing with respect to H2, it becomes a second order system. For H1 only first order system. So now take a simple 1 by tau 1 s plus 1, 1 by tau 2 s plus 1. So let's say they are non-interacting. They are non-interacting. Then if tau 1 is equal to tau 2, then what happens is, let's say, then what happens is, what is y by x? 1 by tau square s square 2 tau s 2 tau s plus 1. So the zeta is equal to 1. Zeta is equal to 1. That means it is a critical damped system. Critical damped system. Suppose if tau 1 is not equal to tau 2, then if you take some example, let's say tau 1 equal to 2, tau 2 equal to 3, then it becomes a over damped system. This is in case of non-interacting. But interacting are always over damped. That is, they are slow. Over damped means theta is higher, no? Greater than 1. Non-interacting is also over damped except one case, when tau 1 is equal to tau 2. So this is what is some important points in second order systems. Let's take another example. So can you sketch the response of these two systems, 4 by 2s plus 1? Suppose if I force this system by 1 by s, the response is y1. And I take 3 by s plus 1 by s, the response is y2. Can you sketch the response of y1 and y2 as a function of time? So what is y1? Can you just write the answer? kpi into 1 minus e power minus t by 2. So that means what is y1 is 4 into 1 minus e power minus t by 2. y2 is 3 into 1 minus e power minus tau. So what is dy1 by dt at time t equal to 0? This will give slope. What is dy1 by dt at time t equal to 0 is 2. What is dy2 by dt at time t equal to 0 is 3. What is y1 of infinity? 4. What is y2 of infinity? Is 3. Now if you plot the response of y1 and y2 with respect to t, you have to put 3 bars. One is 4, another one is 3. The first one is initial slope is less. Initial slope is less means it starts with a this is y1. What is y2? This is what is y2. See how this graph comes is, see what is y1 of infinity? 4. So y1 of infinity is 4, final value. So final value. So but its slope is less. That means it is a slow system. But y2, its slope is high, so it should be faster. But its ultimate value is less. Now, suppose if I connect these two systems something like this, 4 by 2s plus 1, 1 by s, y1, 3 by 3 by s plus 1, 1 by s, plus minus y. Now can you plot the response y? This is y2. So y is nothing but y1 minus y2. So we have already solved y1. y1 is 4 into 1 minus e power minus t by 2 minus 3 into e power 1 minus t. This is y. Can you calculate what is dy by dt and what is y of infinity? Always for plotting the response, you calculate this two. Dy by dt at time t equal to 0. dy by dt at time t equal to 0. Minus 1. What is y of infinity? 1. How do you draw this curve? Y as a function of t. How do you draw this y as a function of t? So let's say this is 0. So the final value is 1. What is negative slope? Negative slope means it goes like this. The ultimate value is positive. The ultimate value is positive. So this kind of response. When you start, it goes in the negative direction is called as inverse response. What is meant by inverse response is slope negative initially. So this kind of systems are called as inverse response with positive gain. So basically when you see y of infinity 1, you will expect that it will go like this. You will expect. This is how you expect. But this is what is reality. So the reality is your initial slope is negative. So let's say if you're talking about this as a temperature. So temperature is right now 60. But the steady state predicted is 70. So you expect that 60 will become 61, 62, 63, 64, 65, 66. But what happens in reality is 60 will become initially 59, 58, 55. Then it slowly picks up from 55, 55, 56, 56, 57, something like that. So these are called as inverse response with positive gain. So we're getting this graph. Negative sign. This is plus and minus. Inverse response means from wherever it is started, initially it will go in the reverse direction. Suppose if you're talking about a temperature of 60, since it is a deviation variable, so I put it as 0, starting value. Suppose if you're talking about level, it starts from 2, then initially it goes to 2, 1.5, 1.1, something like that. So what is y of y dy by dt? So you have this one, no? Let's differentiate with respect to t. Then what happens? 4 by 2 into e power minus t by 2. This is dy by dt. Minus 3 into e power minus t. Put t equal to 0, then you will get minus 1. What is y of infinity? Directly put t equal to infinity. Then you will get y of infinity equal to This is some interesting responses. Inverse response with positive. I think we'll stop it here. Daily I'm taking only 1 hour. So I'll take doubts. Then we'll have one more class in chapter 2. With that one, chapter 2 will be completed. Then only one more chapter remaining, chapter 5. Lab back, my. This is a second order system. Yeah, I need 3-4 classes more. See, how to understand a given response is inverse response. Just calculate the sign. If the initial slope is negative, it is inverse response. 0 in the right half of the plane. That means you have s plus 2. So you have to take one example and then solve. Then you will understand whether it is inverse response. Chapter 2 is almost completed tomorrow. And we have only one chapter remaining, chapter 5. Yeah, two first order systems connected in series will make second order systems. Okay, thank you all.